So welcome guys, today we'll be talking about Python tuples and let's seriously start again. So what's a Python tuple? Like in the previous video we discussed about lists. Lists are data collection. Lists are a data collection that can be used to store different types of data, and those can be int, string, float, whatever. But as we can see here, Python tuple is used to store immutable type of objects. Immutable in the sense these are also the same as they cannot be in any order or any set type of data set. Tuple is similar to lists since the value of the item stored in the list can be changed, whereas the tuple is immutable. Immutable in the sense the data types in it cannot be changed. One stored, that is t1 is equals to 101 peter 22, it cannot be changed. If we want to change it, we can surely use different methods such as changing it to a type of list and then changing the values in it. So let's first see, according to this, how to create a tuple. So tuple can be written as collection of comma separated values enclosed with the small brackets. The parentheses are optional, but it is a good practice to use. Let's have a closer look to it. In list type, if we wanted to store data, suppose 1 2 3 4 and A, B, in tuple, instead of square brackets, we use not the curly braces but the round brackets, and then we store it 1 2 3 4 A, B, and then let's print list, print tuple. So you can see, as we stored it, we got the same type, we get the same thing here. And if you want to check what type it is, so we print the type, so as to assure that these two are different things and not the same thing, as list is not a tuple and tuple is not a list. So you see, for our list that we stored, or let's say list, it has a class of class list, and the other thing has a class of tuples. Now we'll discuss about classes, objects and other things later, but for now let's know that classes are almost similar to some predefined functions or predefined functions that can be used to make different objects and used in variety of types. So here there's an example in which we can create an empty tuple. That is, if you want to create an empty tuple, we can have as t is equals to nothing, just round brackets. Same can be done with a list. That is, if you want to print a list, it will print the same tuple and it will say print the same type. But if we run, we'll get list is equals to this and tuple is equals to this. Now just don't go by the names, these are just variable names. If I just change this to t and l and we print as t and l, we get this same thing that we were getting by the previous variable names such as list and tuple. So let's see other site in which we can see that tuple items, we can see a bit of definitions here, that tuple items are ordered, unchangeable and allow duplicate values. That is, unlike list in which we cannot allow duplicate values, tuple can also have duplicate values, and but those are unchangeable. These are ordered in the sense that the order which we specify, they will remain the same it is, unless and until we try to change it by using some sorting, hashing, or searching arrays or algorithms. Tuple items are indexed. The first item has index 0, just as an array, and the second item has an index 1, third as 2, just as the same as an array. So arrays, lists, and tuples have one thing in common, that is their index numbers. Let's talk about their ordering. So what do we say when we say that the tuple is ordered? It means that items have a defined order, and that order will not change. Suppose if I have a tuple city1 is equals to 1 4 5 52, sorry, 8 4 9, and you try to print it, these do not change to an ascending or descending order but remain same. Even though if we apply any operation for ascending and descending order, or try to change it by some predefined algorithms and not having the correct algorithm to change, and first to change it to list and then change, until and unless we don't do any forceful brute force type of algorithms, we won't get any specific answers and the order will remain unchanged. So we have the same thing again here, that unchangeable tuples are unarranged, meaning that we cannot change, add, or remove after the tuple has been created. And allows duplicates, that is, since tuples or tuples are indexed, they can have items with the same value. Now we can say tuples, we can say tuples, it doesn't matter until and unless you know the same function and the same variable. So this is a small program that demonstrates that tuples can have the same type of variable and allow duplicates, order remains unchanged. So apple, banana, cherry, apple, cherry, apple, banana, cherry, apple, cherry, it's the same ordered and unchanged. So here's a short function that if you want to allow tuple length to determine how many items a tuple has, use the length function. So this length function has also been used for strings such as length string. We can use it for an array, we can use it for a list. Now we will be using for tuples. It remains unchanged because after all Python was created for the ease of use and not to create any confusions within the mind of the programmer. So we run and we get the answer as 5, which is 1 2 3 4 5. Again I repeat, this is the number 5, this is the length, and if anyone is assuming that we will get 4 because it has the last index value is 4, I repeat, 4 is the last index value and not the length of the array. Indexing is just referencing to it. The actual length is the number of items in it. So here we have creating tuple with just a single item, and let's see an example here. This is quite a noticeable example. So we have two things here. This is another thing and this is another thing. Can you tell me the difference between this and this? Okay, let me first not print the type, but let me first print it solely the answer. So just a minute, let's comment it and run it. So you see, this gives us an apple. Okay, the thing that we had seen, although it has a comma. And now let's print this. You see, it gives an apple without the curly braces or any round braces or any semicolons. So what does this mean? This means that this tuple and this tuple, and let's name it this tuple 1. So this tuple and this tuple 1 are not the same. That is, this is a different thing and that is a different thing. So to check what is the type of this, let us have the function of it. So we check the type of it, and when we click the run, we get this is a tuple and this is a string. So what's the difference? I mean, all this is the same. It's in round brackets, it's in this, it also has this thing. The main difference lies between the comma that we placed here and the comma that was not placed here. Having a comma creates a significant difference because when we place a comma, it signifies that there are many more items, or we can say that it's not a single item but a list of items. Although we have not defined the other list of items, but we can say there's a blank space for more list of items. So that's one quite a pretty example, a small mistake which you can run through and you can see through. Next are the tuple data types. That is, tuple can be a string, either tuple can be a string, either tuple can be int type, or tuple can be a boolean type, or else tuple can be a mixed types. It can contain all within ones. That is, it can have strings, it can have integers, and it can have boolean values all in one tuple, just as a list or an just as a list. So that's not a problem, and unlike arrays that can store only one type of data type. So we have previously seen that what's using this type function, we can check that the type of tuple, the type of thing that we are stating is either a tuple or a string or a list that we have checked here for this statement. So that's repeated again. Next, let's perform some functions. So if this is a tuple t1 is equals to 1 plus 2 plus 3, no, 10 plus 10 comma 20 comma 30 comma 40 comma 50, and there's another tuple 90 comma 80 comma 70 comma 60 comma 50, and now we want to see the sum of tuples according to the index numbers. So we create a for function for I in t1 and t2 and we pre-declare sum is equals to 0. So sum is equals to t1 plus t1 I and we print sum. So can you guess what will be the answer, and will it print the correct answer, that is 10 plus 90 100, 20 plus 80 100, 30 plus 70 100, and so on? Let's see. So as you can see, now what's the mistake? The mistake is that tuple is out of index. That is, this I is not referring to the index numbers, that is 0, 1, 2, 3 and 4. It's referring to T1. So when I go to T1 and T2, it first gets confused in 10 and 90. So the I stores 90 and now there is no index number of 90. So it the tuple range is out of index, that is the tuple index is out of range. I is equals to 90, so that cannot be possible. So to get in line, what we do is, in range 5, you see, now we get 100. That is what it will be performing. T1 0. First, this for loop, this range will go from 0, 1, 2, 3, 4. Okay, let me give it a different line. So this will go T1 0 plus T2 0. Now that will account to 10 plus 90 equals 100. So it prints in the first line 100. Next, these both go to 1, that is 1 and 1. So this time we get 20 for T1 plus 80 for T2 is equals to 100. So we get the answer 100. Similar for 30 plus 70 equals 100, 40 plus 60 equals 100, 50 plus 50 equals 100. So this was a small program that we did to first of all get a common error that we might get in for loops or in tuples, and the second thing, that index numbers variate according to the tuples given, and they can be used to perform different operations of a program that are stated. Okay, so here's another problem given here. Let's try to solve it. I directly copied it because I didn't want to waste any time. So in this line we are seeing, let's have dry run first and then we'll have the computational experiment. So in tuple 1, first of all we are taking the number of elements that the tuple will store. The tuple will store, if we suppose enter 5 or we say 10, then it will create 5 blocks, 10 blocks, 1 2 3 4 5 6 6 7 8 9 10. Yes, it will create 10 blocks in which numbers can be stored, and then it will print tuple 1, which will be an empty tuple. Next we have a count as 0, and for I in tuple what we do is, let me show you the program first. So we enter 10. So what did we get? We get 1 0. It didn't store a 10, it stored as 1 0. What if you want to give double digit number? We print it again, 1 0, 2 0, 3 0. We add a space and not an enter. Oh, so you see here, it is taking this as not a space. So this is different program that I wanted to state, but the logic behind it is same. That if we wanted to store, let me clear this up first. Just a minute, it's connecting to the kernel. Yes, so we want add 1 2 3 4 5 6 7 8. Okay, so the logic behind here is, that first we enter the tuple elements, that is we entered 1 2 3 4 5 6 7 8 without any spaces, because space will be counted as a string, unlike lists where you can store with spaces, or I think it can be only stored in C++. On this we can say that it takes without a it takes the space as a string. So it creates, with next line we print the tuple, it prints the tuple as 1 2 3 4 5 6 7 8. Next we have a count is equals to 0, that is we take, let's have dry run, count is equals to 0. For I in tuple 1, I goes in tuple 1, that is 1. Print tuple 1, that is tuple, this percentage and d refers that the number here will be a decimal and not a string. So this decimal is equals to string. We are referring this 1 as a string and not as an integer. Why? Because int can be taken as a string, and strings and floating points or strings can also be taken as strings and can be performed various operations. But a string cannot be taken as an int and performed the operations that we intend to do. So we take the count as 0, we have the count 0, and I, that is it takes, prints the first element in the 0th index, then the second element in the first index, and so on. Next we have some more basics, and not it's not basic, but we can say that these are some advanced level of things, that is tuple indexing and slicing in the sense if we want to print only a set number of characters, or from 2 to 4 or 1 to 3, as we did in strings or in list, that we want to print number of elements in a set number of arrays, we can do that in this also. Next we have the negative indexing, the same as we did in the arrays or in the list, that if there are 5 elements in this, suppose we have 1 2 3 4 5 6 elements, and if we want to print the minus 1th element, we'll get it as 7 and not that index is out of range, because if this is from 0 to 6, this is from minus 1, 0 to 5, this is from minus 1 to minus 6, this to it. Here's a short again, here's a short program again. So if there's a tuple, say tuple 1 is equals to 0 comma 2 comma 3 comma 4 comma 5, we print the tuple, and then we delete the element. Print the tuple again, and then we delete the whole tuple. And we print the tuple 1 again. So in this one we are just basically creating a tuple by our own and then printing the tuple. In the next line we are deleting the element at the 0th location, that is 0, and then it should print the tuple from 1 to 5, and then we are deleting the whole tuple, and we are printing the tuple 1, and let's see what do we get here. So you see here, for the first one we get that it was a tuple 1, we get it as printed. For the next thing, you can see that as we try to delete the element and print any of these, what the thing we get is the tuple object doesn't support item deletion. If you would remember, in the previous thing, or in the starting, or in the beginning, we discussed that tuple are not interchangeable. So if we try to changing in the sense deleting, adding, inserting, or sorting kind of thing, we can't do that thing here in tuples. But if we want to delete the whole tuple as alone and then print the tuple, it can be done, because we are not changing, we are just trying to delete it. Here are some basic tuple inbuilt functions, that is comparing two tuples or having the length, printing the maximum element in the tuple, printing the minimum element in the tuple, printing tuple sequence. It converts the specified sequence to the tuple. So if there is a list, let's do these both functions, minimum and minimum maximum and tuple, with a change in it. So suppose if there is a sequence 1 comma 2 comma 3 comma 4 comma 5 comma a comma b, and we print t1 is equals to tuple of seq. So ideally it should print the sequence if it's a list in a square brackets, but let's see what will it have when we try to print it. So we are here printing the type and we are here printing the sequence. So you see, we have not changed it into tuple. Why? Because we are printing here the sequence and we are not printing here the t1. So sequence is a list, but if we try to print t1 and check its type, we see that the sequence that was originally a list has been stored in t1 as a tuple, and when we try to print its data type, we get it as tuple and not a list. Let's have a sneak peek into this maximum and minimum functions. So let's say tuple is equals to 1 comma 2 comma 3 comma 4 comma 5 comma 99, print max of tuple, print min of tuple. So here we can see the maximum is 99 and the minimum is 1. Now let's have a twist in this. What if we try to print a comma a? What will be the answer? The maximum one is a, the small one, and the minimum is capital A. Why? Because small a has a ASCII value of 97 and the capital A has an ASCII value of 65. So ideally when we are talking about a character, we check its ASCII value. Now let's say if we add a string here, so the maximum one here is a king and the minimum one here is a joker. Now why? Because we are comparing it in a string and not the sky value, but things are taking position about for a dictionary, or we can say alphabetical order, according to which the element or the string with the most elements coming in the right alphabetical order, or in the shortest term we can say that will be the maximum, and the set number which has a more number of characters will be having as a minimum. So we have here various functions that you can check upon on yourself and have a learning on it. Okay, thank you. In the next one we'll be studying about sets or dictionaries. So hey guys, today we'll be concluding the basics of Python on a very serious note, and then from the next forward lectures we'll be having intros, and we will be having a deep look into the data science and the modern Python world use that can get us to great heights. So what are Python dictionaries? As you can see, here's an example that we are, unlike lists in which we use square brackets and tuples in which we used the round brackets, in dictionaries we use the curly braces. And we can see that here is the thing: we have defined a brand is equals to Ford, model is equals to Mustang, and the year as 1964. So what are dictionaries? Dictionaries are used to store data values in key and value pairs. That is, this brand, model, and year are all the keys. Keys in the sense that defining parameters, and these are the values of those parameters, the value pairs, as we would say in a dictionary. A dictionary is a collection which is ordered, changeable, and does not allow duplicates. As of Python version 3.7, dictionaries are ordered. In 3.6 and earlier, dictionaries were unordered. So if you want to check, as I told you, the version of Python which you are using, just type a py in your command prompt and you'll get here 3.9.7. Since I have a 3.9.7, so my dictionaries will be ordered. Dictionaries were written with curly braces and have keys and values. Suppose if we have this small program and let's run it all together. So when we run it, we get it in the dictionary form, that is brand as Ford, model as Mustang, and year as 1964. If you want to check the type, print type this dict, it as class dict, that is a dictionary. So dictionary items are ordered, changeable, and does not allow duplicates. Dictionary items are presented in key and this colon and value pairs and can be referred to by using the key name. Like if you wanted to print a brand of it, so we take it as this dict brand, and when we print it, we get it as Ford. If we wanted to print the model of which we are storing in it, model print Mustang. See, it's easy as well. So when we say that dictionaries are ordered, it means that the items have a defined order and that order will not change. Unordered means that the items does not have a defined order. You can refer to an item by using an index. Changeable dictionaries are changeable, meaning that they can change, add, remove, or dictionaries after the dictionaries have been created. So if I wanted to change, suppose the model to mm, Toyota. And now when we print this dict, we get the same as Ford Toyota 1964. You see the model here changed it from Mustang to Toyota, which we tried to alter in the line number 9. So duplicates are not allowed. Dictionaries cannot have two items with the same key. That is, if there is a brand Ford model Mustang and there are 2 years stated in it. Let's have an actual run here. You see, if there are duplicates, it will replace the value with the latest thing, and you can see we have a error here. The smart analysis shows us the error, the dictionary key year repeated with different values. This is not according to the pyflex e rule, and thus it will store the latest value, that is the 2020, and display it. Again we have the function of length. So like we use the length function in strings, arrays, strings, arrays, lists, tuples. We have the same in for dictionaries, and this will print 3, that is brand, model. And although there are 2 years, but it doesn't allow a duplicate, we count this whole as 1 and we get it as 3. Next up we have dictionary items, that is data types. So the values in dictionary can be of any data type: string, integer, boolean, list data types. You can also store a list into the whole dictionary. The value pair, as we would say, like we discussed here, that this is a key and this is a value pair. The value pair can also be a list, can also be an integer, can also be a string, and it can also be float. If we like checked in this one, if we type the type of the dictionary that we stated here, it will print it as dict, uh, proving it that this is actually a dictionary and not any other variable type, ruling out the condition. So this was the end of the basics, and in the next videos we will see what are the basics of data science and machine learning. So let's have a brief input here. Brief recap. List is a collection which is ordered, changeable, and allows duplicate members. Tuple is a collection which is ordered, changeable, allows duplicate members. Set is a collection which is unordered, unchangeable, and unindexed. It does not have duplicate members. Although we did not have a look through it, we can always have a look through it through the site here given it as w3school.com. And dictionary is a collection which is ordered and changeable, and it has no duplicate members. So this was all for the Python basic parts. Let us see the intermediate part and the data science part in the next series.